Hello class, welcome to this video on the EOC review. So part 6. So let's go ahead and get started. So let's continue 5.3, or GR 5.3, construct inscribed and circumscribed circles of a triangle. So number 1, find the perimeter of the triangle given the distances. So here we are. So this is sort of what we did recently with tangent lines. These are tangents, right? They cross a circle at the one point here. 3 separate tangent lines. So we know that these are going to be congruent, these are going to be congruent, and these are going to be congruent. So if this is 12, this is 12. If this is 8, this is 8. If this is 12 and this is 16, then this has to be 4 because 16 minus 12 is 4. And if that's 4, this is 4. So we can go ahead and get the perimeter. Let's add up all the sides. That's 12, that's 20, and they already told us that that's 16. So then the perimeter is just the sum of those sides. So I got 28 plus 20, so the perimeter is 48 centimeters. All right, so pretty straightforward if you remember that rule. Number 3, the center of the inscribed circle of a triangle has been established. Which point on one of the sides of a triangle should be chosen to set the width of the compass? So let's say we have a triangle. So remember what we were saying about the center of an inscribed triangle. An inscribed triangle means that, an inscribed circle means that we're talking about an end circle. And an end circle means an end center, sorry, an end center. And an end center means we're talking about an angle bisector. Because that's, remember the acronym that I mentioned earlier. So my cousin always owes Anna banana ice cream, probably before Christmas. So here we got angle bisector, end center, and that's exactly what we're talking about. So in order to do that, we would need to construct the angle bisectors, right? And then where they cross is where the center of the circle lies. But in any case, so this is the end center, so we got an inscribed circle. And all you need to know is that it's inscribed and that the radius of the circle has to be perpendicular to that tangent. Remember, this is a tangent line here, right? And so in order to figure out like how to draw the circle, you would need the radius. This is where you would set the compass. You would set the compass at a distance from the center to a right angle to the tangent. And that's the compass setting that you want to use. Okay, and then that's how you'd be able to draw the circle. Because remember, when you're constructing it, you don't have the radius of the circle when you're actually making it. All right, so you would have to define the intersection of the side of the circle, which is the tangent line, and the perpendicular that goes through the center, which is like the radius. So that's C. All right, so which statement is valid when a circumscribed circle of an obtuse triangle is constructed? So circumscribed circle, remember that's going to be PBC, probably before Christmas. Perpendicular bisector, and then this is your circumcenter. Okay, so if you have a triangle that is obtuse, right, this is an obtuse triangle because this is an obtuse angle there. Then you're going to construct perpendicular bisectors. So what's perpendicular to this guy? It's going to be right around here, and that's cut that in half. That's perpendicular, cuts it in half. Here, this is perpendicular and cuts that in half. Here, this is perpendicular, and then it cuts this in half. So the circumcenter is somewhere there. We'll call that point C. And then the circle, the circumscribed circle, remember, is the same distance from each of these vertices. So this here, and this here is actually your radius, right? It's the same distance. And so then you can draw your circle with that radius. And so let's go ahead and answer the question. The longest side of the triangle lies on the diameter of the circle. No, that's a chord. The longest side of the triangle is actually the chord of the circle, but it's not the diameter, not necessarily. The circle is drawn inside the triangle. No, the circle is outside the triangle. The center of the circle is in the interior. No, it's on the outside. The vertices of the triangle lie on the circle. Yes, the vertices lie on the circle itself. So that's answer is D. All right. So this is an honor standard, so we can skip that. There are no questions that I gave you there. Let's skip the honor standards. There's another honor standard. I think the next page over is honors as well. Yeah, so this is honors, and then this is honors. So we can skip over to the next page, 33. All right, GR 6.1, solve mathematical real-world problems involving length of secant, tangent, segments, or chords. So this is a more recent topic with the chapter on circles. So remember, if you have two tangents or secants or whatever crossing on the outside of the circle, then in order to get the length, you would have to multiply the outer portion times the total length, right? So that's how we do that. All right, so let's go and do that. So they're looking for RS, so we're going to call that X. All right, so it's going to be 7 times 7 minus X, or 7 plus X. So we got 7 times 7 plus X is equal to, and then do the outer portion, which is 11, times the outer portion, which is also, or the outer portion, which is 11, times the whole thing, which is also 11. So it's really 11 squared. All right, so then we can solve this distribute. 7 times 7 is 49. 7 times x is 7x. 11 times 11 is 121. And then we'll solve. Subtract 49. And we are left with 72. Divide by 7 on both sides. So x is approximately 10.3. We're going to round to the nearest tenth. All right, number 2. What is the measure of angle QPS? So for this one, you have to know that in an inscribed polygon of a, if you have a polygon that's inscribed in a circle, then that means that the opposite angles add up to 180. They're supplementary. So in this case, this and this add up to 180. So you have 3x plus 8 plus 5x plus 4 equals 180. And the reason they add it to 180 is because this angle is inscribed and it covers that portion of the arc, and this angle is also inscribed, which covers this portion of the arc, and so they cover 360. But because they're inscribed angles, remember you got to cut you got to cut it in half, so it's really 180. Okay, so that's the basic premise. So you're going to solve for x here. So let's combine like terms. 8x plus 12 equals 180. Subtract 12 on both sides. 8x is equal to 168. Divide by 8 on both sides. So x is equal to 21. Well, that's not the final answer because we got to find QPS, right? All right, so now let's call this y. So now we know that these two add up to 180, right? So 6x minus 14 plus y has to add up to 180. Well, we know x now, so we can plug that in. So 6 times 21 is 126. 126 minus 14. So let's do that real quick because I'm having a brain fart here. 126 minus 14, so 112 plus y equals 180. Subtract 112 on both sides, so it's going to be 68. All right. So now we have two chords that intersect. Remember that if they cross on the inside, then you simply have to multiply the two pieces. So you would do x times 5, and then you would do 2 times that. Okay, and I should probably code these differently. So x times that, and then 2 times that. So 5 times x equals, and then 2 times that. So distribute. 2 times 3, and then 2 times 2. Let's see, subtract 6x on both sides. So you get negative x equals negative 4, which means x is 4. Then you're going to plug that in to get kz. Well, let's plug it in to get this first. So we get 3 times 4 minus 2 is 12 minus 2 is 10. So this is 10 and this is 2. So then 2 plus 10 is 12. KZ equals 2 plus 10, which is 12. All right, so number 4, what is the value of A? So this is another outer one. It crosses on the outside. So that means we got to do the outside times the whole thing. 5 plus 12 is 17. And then the outside times the whole thing. But the whole thing is 4 plus A. We got 5 times 17 equals 4 times the whole thing. 4 plus A. Distribute. 5 times 17 is 85. 4 times 4 is 16. 4 times A is 4A. Solve. Divide by 4. Get 17.25 on the calculator. All right, so number 5, AB equals 9x plus 3, CB equals 8x plus 6. What is AB times DB? Be careful, they're asking for AB times DB. They cross on the outside, so you got the outside times the whole thing, right? And they said that they said that the whole thing is 9x plus 3. And you gotta do outside times the whole thing. And they said the whole thing, CB, is 8x plus 6. Okay, so let's set it up. 7x times 9x plus 3. The outside times the whole thing equals outside times whole thing. 6x times 8x plus 6. All right, so we're gonna solve this. We're gonna distribute. So 7x times 9x is 63x to the second power, x times x. And then 7x times 3 is 21x. 6x times 8x is 48x to the second. 6x times 6 is 36x. All right, so this looks like we have x squareds and x's. Let's move everything to one side. I'm going to move this over here. And I'm going to move this over as well to the left side. That way these cancel, leaving me with 0 on the right side. On the left side, we have all the x's together. So this is going to be 15x squared minus 15x. Now this is a quadratic, so you can use the quadratic formula, but you can also factor. So I'm going to pull out a 15 and an x here. So we can pull out a 15, we can pull out an x. Now, if I do that, then this has to be x, because 15x times x is 15x squared. So we're using a little bit of algebra here. And then 15x times 1 is 15x, right? And there's a negative there. So if I distribute, I should get the top part. Now, because this is set up in this way and it's equal to 0, we can say that this is equal to 0 and this is equal to 0. This is called the zero product property, and you definitely have seen this in Algebra 1. However, if you don't remember that, just take my word for it. You're going to factor this out, and then because this is equal to 0, that means both parts are equal to 0. So 15x equals 0, and then x minus 1 equals 0. Divide by 15, so x is 0, and then add 1, so x is 1. So you got two answers. However, it doesn't make sense for the answer to be 0, so we're going to say that the answer is 1 instead, and we're going to plug that in to here and here, or not there. We're interested in AB and DB, so we're going to plug it into DB and AB. All right, so let's do that right now. So AB is 9 times 1 plus 3, which is 12. DB is 7 times 1, which is 7. And then multiply those together. AB times DB is 12 times 7, which is 84. Okay, yeah, there's a lot involved in some of these problems, so you just got to make sure you read the question carefully. All right, number 6. A drawing of a puffin's head is made up of a circle and two tangents that meet at an exterior point. If AD is 4x minus 5 and AB is 6x minus 27, what is AB? So we know that if we have two tangents that meet at a point outside the circle, then the two tangents must be congruent. So we're going to set them equal. And then solve. I'm going to move the 4x to the right side. I'm going to move the 27 over to the left side, and I'm going to add it because this is a negative. 27 minus 5 is 18. 6 minus 4 is 2. So we got 2x. Divide by 2. X is 9. Then we're going to plug it into AB. 6 times 9 minus 27. Let me make sure. I feel like I messed up something. This is not 18. I'm sorry. This is actually 22. I apologize. Yeah, so 27 minus 5 is 22. Then divide by 2, that becomes 11, not 9. And then we're going to plug 11 into here. So 6 times 11 minus 27 is 39. All right, next page, 34, 6.2. Solve mathematical and real-world problems involving measures of arcs and related angles. All right, so number 1, determine whether each statement is true or false. Okay, so first off, we have a bunch of inscribed angles here. We could tell that this angle here is inscribed because it's on the circle. And if we look at this inscribed angle, we notice that its arc is 116. And therefore, this angle has to be half of that arc. So we already know what this angle is. This angle right here is half of 116. So 116 divided by 2 is 58 degrees. So we know what that is. So that's 58. And then we also want to note that here we got another inscribed angle. And so since that angle is 35, that means its arc has to be double that, right? So that means this arc here has to be double that. 2 times 35 is 70 degrees. Okay. Also keep in mind that this arc here also has that, or this angle, this inscribed angle also has this as the arc. So if this arc is 70, then that means that this angle is half of that. So it's going to be also 35. And we know that these two angles are the same because of vertical angles. And we also know that these two angles are the same because of vertical angles. And we also note that this is going to be 58 degrees because it also has the inscribed angle. It's also an inscribed angle for this arc. So it's got to be half of the 116. All right, so we got those numbers so far. And now we could figure out what this is because those angles add up to 180 because they're in a triangle. All right, so we can figure out what that is. So that is 180 minus 58 minus 35. This is 58 and that's 35. And so that's going to be 87 degrees. Okay? And so this is also 87 degrees because of vertical angles. And to get this angle, this is going to be 93 degrees because of 87 and 93 have to add up to 180. So 180 minus 87 is 93 because they're a linear pair. They form a line. And if that's 93, then this is 93. So we got a bunch of angles there. So we should be able to determine this. So WPZ is 58. WPZ, yes. Or no, that's false. It's actually 93, sorry. WPZ is 93, not 58. The measure of arc XY is 70. Yes, we found that to be 70. That's true. Angle WYZ, YZ, that's 58. That's true. WPZ is 93. WX, the measure of arc WX is 174. Okay, so how do we get that one? That one's interesting. So WX is this arc, and So first off, because we have two intersecting chords, which are, oops, wrong color. These two chords. In order to get this angle, which is, this angle is 93, right? Or no, 87. In order to get this angle, we would have to add this arc and average them to, and divide them by 2. Okay, so let me remind you of that. Let's do that over here. So if I have two arcs, or two chords, sorry, and I want to figure out what that angle is, I have to add the two arcs formed by both chords, both ends. So x is equal to, and I add them up, then divide by 2. Okay? And that's how I get that angle. So, but we already know that that angle is 87. So we got 87 is equal to a plus b divided by 2. Which means that if I multiply by 2, a plus b is 174. And so if a plus b is 174 and a is wx, right? Then there's no way wx can be 174. So this is false. There's no way that it can be that big. And then finally, xpy is 193, so that's true. Okay, so the only one that was a little tricky is probably this one, but the rest should be inscribed angles. All right, the circle graph shows what quality business owners value most in an employee. What is the measure of arc AD? So you want to figure out what that is. But we already know so we know that if I have a circle and then I have a central angle, whatever that central angle is, that's going to be the value of the arc as well, right? The arc measure. So we just have to figure out what this angle is. Okay, so in order to figure that out, let me just use another color, green. So let's figure out what this angle is. To figure out that angle, which is the same as this arc. So to figure this out, we know that since it's 35% of the pi, we just do 35% of 360. And that will give us that angle. So it's going to be 126 degrees. All right, and that's it. Just 35% of 360. All right, so this one, PQT. PQT is 72, so this is 72 degrees. What is the measure of arc QRT? So QRT, okay, so we're trying to figure that out. We'll call that X. Okay, so the theorem states that if I have a tangent and a secant that basically they look like an inscribed angle, but they're actually not an inscribed angle. And what I mean by that is that the vertex is actually on the circle. Then the theorem states that if I have something like that, like this, then this angle is obtained by essentially taking this arc and cutting it in half. So it's that arc divided by 2. That's it. You just cut it in half, just like you would for an inscribed angle. Which means that if this is my red arc, we need to figure out what that is. So that is always going to be double the angle. So double the 72, and that will give me that arc. So 148. See, if I cut that arc in half, that gives me the inscribed angle, which is exactly what this rule says. So just double the angle to get the arc measure. And if this is 148, then that means that this is 360 minus 148 because they make a full circle. And in that case, I get 216. Oh, is it 248? No, it's 244. I'm sorry. It's 144 here, not 148. In that case, yeah, so it's 216. Yeah, 216 degrees. All right, so these kind of work like inscribed angles at the end of the day. So let's move on to 35. Solve mathematical problems involving triangles and quadrilaterals. Involving triangles and quadrilaterals inscribed in a circle. Okay, so quadrilateral FGHJ is inscribed in circle E. If the measure of the arc is 170, this is a typo. It should say 180 there. and this should say 90. Okay. And then this should say 135. So sorry about that. So just fix that. What type of quadrilateral is FGHJ? So, okay, so angle H is 135. So let's do that first. Angle G is 90. And then FGH is 180. Okay, so that's FGH. Okay. And then GHJ. Oh, GHJ. Oh, hold on. Okay, and arc GHJ is 90. Okay. All right, so first off, this is an inscribed angle. And so that means that its arc has got to be double that angle. All right, so that's 90, then this has got to be 90 times 2, which is 180. Okay, so that's 180, which you think about it makes sense because this is a diameter and that's half of the circle. All right, and then this is also an inscribed angle, which means that its intercepted arc is double that angle. So so in order to get that, we just got to double the 135. So 2 times 135 is 270. Okay, so that's this arc here, from here to there. All right. So let me actually mark that from here to there. Okay, and then next we want to note that, okay, so since this is 90, this angle is 90, this has to be 45 because this is an inscribed angle for that arc there, right? So now we know that that's 45. Okay, so in any case, remember that the angles in an inscribed quadrilateral actually add up to 180. So this is 45, that's 135, that adds up to 180. If this is 90, then this has to be 90 right here. So these are both right angles. So because we have two of the same angle that are on the opposite corners like that, this is actually a kite. A kite, recall, has these angles being the same. However, these two, the top and the bottom angles, are not the same. So it's only these two that are the same. All right, so that is a kite. All right, so a company's logo is made up of two congruent isosceles triangles inscribed within a circle. If the measure angle A is 3x minus 4, okay, so 3x minus 4, and measure of arc AE is 100, so AE, this is 100 degrees, what is the value of x? All right, well, so if this is 100, well, then this angle has to be 100 because that's a central angle, which is equal to its arc measure. And if this is 100, then this has to be 100. And if this is 100, then this arc has to be 100. And if this arc is 100, well, then notice that this arc actually covers this inscribed angle. And so we can use the inscribed angle rule. Okay, so for that inscribed angle, remember that the angle is always half of that arc measure. So 3x minus 4 is equal to half of the 100, which is just 50. So 3x minus 4 equals 50. So add 4 to both sides. 3x is equal to 54. Divide by 3. So x is equal to 18. All right, number 3, if the measure of angle B is 3.5 times the measure of angle A, what are the measure of angle A and the measure of angle B? Okay, so angle B is 3.5 times. Okay, so let's call angle A x, right? And so this is going to be 3x. Angle B is going to be 3 times angle A, right? Oh, it says 3.5 times, so it's going to be 3.5 times angle x. Okay, and we know that this has to be a right angle. The reason being is that this is an inscribed angle, and this inscribed angle covers this arc, and that arc is part of this diameter, and so that arc has to be 180, which means half of that is 90. So that's how I know that that's 90. Okay, so so I'm just going to go ahead and say that that's 90. That's a 90-degree angle. And therefore, these 3 angles must be added to 180 because we have a triangle. So we got 3.5x plus x plus 90 equals 180. And we can solve for x. So let's combine our like terms. 4.5x plus 90 equals 180. Subtract 90 on both sides. 4.5x equals 90. Divide by 4.5. So x is equal to 20. And so that means that this angle is 20 degrees, angle A. And then we're going to plug this into there. So angle B is 3.5 times 20, which is 70 degrees. Okay, so the answer is D. All right, so number 4, quadrilateral JKLM is inscribed in a circle. If the measure angle J, so they give us a bunch of angles, what is the value of X? So remember that if you have an inscribed quadrilateral, the opposite angles always add up to 180, right? The opposite angles are, these opposite ones are supplementary. Okay, so let's go ahead and label this. So let's say JKLM. So let's take a look at K and M because they should add up to 180. And also J and L add up to 180 as well. So we'll just do K and J. K and J. So we're going to add those to 180. And then solve. So we got 6x minus 10 equals 180. Move the 10 over. That's 190. Divide by 6. So x is equal to, is it, hold on, it's let me make sure that the math is right here. Oops, I used, so I was trying to do K and M and I ended up doing K and J. I apologize. So I did K, which is 3x minus 12. Okay, I'm gonna go back and erase this. That's what happens. I gotta go a little too fast here. All right, so this is angle K. And then I want to do angle M. So where's angle M? That's 5x minus 24. Those should add up to 180. That's angle M. All right, so add the like terms. So that's 8x minus 36 equals 180. Move the 36 over. 8x equals 216. Divide by 8 on both sides. So x is equal to 27. There you go. All right, so now we're on the next page, page 36, GR 6.4, solve math and real world problems involving arc length and area of a sector. All right, the fuel gauge of a car represents how much gas is left in the tank. If the area of the sector represented by the fuel gauge is 10.6, how long is the gauge needle? All right, so let's go over the formula for the area of a sector. The area of a sector is equal to the angle over 360, the central angle, over 360 times pi r squared. All right, and usually we call the central angle theta, right? That just means angle. All right, so here we got the central angle is 135 over 360. Oh, actually, let me just do this over here. So the area of the sector, they tell us is 10.6. So 10.6 equals, and then they say that the angle is 135 out of 360 times pi times the radius squared. Now the length of the needle is roughly the radius of that circle. So we're going to use that as the length of our needle. All right, so basically we're going to convert this to a decimal, and then basically we're going to, so let's do the reciprocal. So let's multiply by the reciprocal. So these cancel, and then we'll and then we can divide by pi as well. So we'll put pi over here so that it cancels. So basically we're just multiplying on the top or dividing on the bottom in order to cancel out the opposite guy. So times 360 over 135 pi. Whatever we do on one side, we got to do on the other. So basically it boils down to doing 10.6 times all of this. So let's figure out what that is. So r squared is equal to, so let's do this on the calculator. So doing that on the calculator gives you, I believe it should be, let's do that over here, 360 over 135 pi. Okay, so I went ahead and typed it in here, and I got about 8.99. So this is about 9, basically. So I get about 9, interestingly enough. Okay, so this is about 9. And then if I take, then to get r, I got to take the square root. So r is approximately 3 centimeters. All right, number 2, high school media newspaper asked students about the main reason they use social media. 45% post videos, 32% communicate with friends, 21% use social media, 2% use social media for other purposes. The newspaper plans to publish results using a circle graph. If the length of the arc that represents communicating is 5 centimeters long, what is the approximate radius? So this is 5 centimeters, that's the arc length, and communicating with friends is the percentage of that was 32%. So this was 32% of the pie. So we would have to figure out what this angle is. Now that angle is not hard to find. Remember, it's 32% of 360 is what that angle is equal to. So we can do that. 32% times 360 is 115.2 degrees. So that's what that angle is. Okay, so the arc length, if you remember that formula, is equal to the angle over 360 times 2 pi r. Now the angle over 360 is the 115.2 over 360. And then 2 pi times the radius. The radius is 5. And that's how we get the arc length. Or no, wait, the arc length was 5. I'm sorry. We need to find the radius. We don't know what the radius is. So the arc length is 5. So remember that this is equal to the 0.32 that we found here. That's actually equal to 0.32. So in this case, we get 0.32 times 2 is 0.64. So we get 5 equals 0.64 pi times the radius. Divide both sides by all of that stuff. And so we can get r is equal to 5 divided by 0.64 pi, which if you did that would give you roughly almost 2.5 centimeters. All right, number 3, Juan is making a daily schedule clock to help with his time management. Every day between 4 and 6, he should work on homework. If the clock he's using has a radius of 12 inches, so that's the radius. What is the approximate area of the homework sector? So area of the sector, remember, is angle over 360 times pi times radius squared. So we need to figure out this angle. But this angle is not hard to find because this angle represents how much, well, okay, so let's go ahead and we know that this here has to be, well, we know there's 12 parts to the circle, to the clock, and we're covering 2 parts of the clock. So this is actually 2/12 of the clock, right? So basically the theta over 360 can be replaced with 2/12 of the clock. And that's the quick way of doing it. And then pi times the radius is 12, so 12 squared. Remember, this is just a fraction of the coverage. So here we have 2/12 of the clock, which is 1/6. So this is actually 1/6 of the clock is being covered. And 12 squared is 144. So do this math, and then you get 75.4 inches squared. All right, number 4, one sector of a circle has an area of 11 square meters and an arc measure of 35 degrees. What is the area of the circle to the nearest centimeter or square meter? So the area of a sector is equal to the fraction of coverage times the area of the circle. And I didn't normally I would say pi r squared, right? I would say that this is area angle over 360 times pi r squared. However, pi r squared is the area of a circle, so I'm going to just call this area of a circle. And the reason being is because we want the area of a circle. All right, and it says the area of the sector is 11. So this is 11, and the angle is 35. All right, so in order to get rid of this 35 over 360, I'm going to multiply by the reciprocal on both sides. And then 360 times 11 divided by 35. I just got to do that on the calculator. So I get 113. It's a decimal, so I just rounded it to 113. All right, the next one is an honor standard, so we can actually skip that. Yay. So now the next page should not be an honor standard. We're going to do page 38. All right. All right, so given a mathematical or real-world context, derive and create the equation of a circle using key features. So, all right, so this is some topic that I didn't go over, at all. So I want to make sure that I give you the time to kind of talk about this. We did talk about circles, but we didn't talk about equations of circles, just because of the sake of time. We didn't, EOC came back too quickly. And so we didn't get a chance to kind of dive into that. So the equation of a circle, I'll put it over here. The equation of a circle in standard form, this is in standard form, is x minus h squared plus y minus k squared equals r squared, where r is your radius, and then hk is your center. Okay, so that's the equation of a circle. Now, in order to get an equation into that form, there's a lot of work that goes into it. So I'm going to show you how to get the this equation, which looks complex, into this form. Okay, so again, we want to make sure that it's in this form, which right now it looks nothing like that. So let's go ahead and show you how to do that. So first off, I'm going to divide everything by 4 just to get rid of those numbers, because those numbers are, a little bit annoying because they're making the equation look bigger than it actually is. So we're going to divide both sides by 4. And that gives us x squared minus 4x. And I'm going to leave some room here. And then I'm going to leave a little bit of wiggle room here and put this in parentheses. And then 4y squared divided by 4 is just 1y squared minus 24y. Again, I'm going to leave myself, or 24 divided by 4 is 6, so this should be 6y. 24 divided by 4. And then 16 divided by 4 is 4. I'm going to leave some room here, and I'm going to put the plus 4 out here, equals 0. And then what I'm going to do is I'm going to move this 4 to the right-hand side, because I want to get rid of it. All right, and what that does is it turns it into -4 on the other side. Okay, I'm erasing that just because I don't want to run out of space by writing too many steps, okay? So I moved the plus 4 to the other side. Now next I need to do something called completing the square. All right, so completing the square, what that means is I need to essentially find a number here such that when I factor this, it gives me something that is a perfect square, meaning something that repeats. Okay, so let me explain what that means, completing the square. Okay, so completing the square means that, so for example, if I had x minus 4 to the second power, just as an example, in order to do this, I need to FOIL it, right? X minus 4 times x minus 4. And some of you guys remember first, outer, inner, last, right? So first is x times x. So that's FOIL, first, outer, inner, last. So outer is x times -4. Inner is -4 times x. Outer is -4 times -4, which is 16. And so notice that this becomes x squared minus 8x plus 16. And so what I want to do is I want to go from this form to that form. And so let's say I had this, but I had no idea what this was. Let's say I had no idea what that was. How would I be able to fill in that number without knowing what it was to begin with, right? That's what we're doing. This is called completing the square. Because by filling in this number, it factors into this, which is a perfect square. And so the trick to this is to take the middle number divided by 2 and square it. So 8 divided by 2 is 4, and then 4 to the second power is 16, and therefore this gives us what we need. And that's what you always do. So for example, if I were to do x minus 2 squared, well then in order to do that, well, it's going to be x squared minus, and it's going to be 2 squared is 4, right? So 2 times 2. And then to figure out this, what I would need to do is I would need to do negative 4 divided by 2 and square it. And that would give me 4 divided by 2 is 2, 2 squared is 4. So this would have to be 4. And if I did that, it would give me that. Okay, so that's called completing the square. All right, so that's what we want to do. So what we're going to do is we're going to take this middle number, which is, we can ignore the negative, divided by 2 and then square it. Same thing here, this middle number divided by 2 and then square it. And so that gives us 4 and 3 squared is 9. But remember, if I add something on the left side of the equation, I must add it on the right side of the equation. So I really have to add the same thing, right? I can't, otherwise it's not going to be balanced. All right, so we said that this was 4 and then this was 9. So negative 4 plus 9 is 9. Okay, so remember, the reason why we filled in that third number is because we wanted to make this into a perfect square so that it looks like this form where it's 2 numbers raised to the second power, right, with a variable. All right, so let's go ahead and factor this guy. How do we factor that guy? Well, remember how to factor your quadratics. In order to factor this guy, we need to find 2 numbers that multiply to negative 4, but add up to this number 4, positive 4. The only numbers that works for is negative 2 and negative 2. Or no, negative 2, sorry, I reversed it. It's 2 numbers that multiply to 4, I apologize, positive 4, but added to negative 4. I reversed the order. I reversed the numbers. They have to multiply to the last number, but add to the middle number. And that's going to be negative 2 times negative 2. Negative 2 times negative 2 is positive 4, but when you add them, you get negative 4. All right, and that becomes x minus 2 squared. Remember, we did that over here. X minus 2 squared. When I FOIL that, I get this. And this is exactly what we just filled in. All right, so we're just kind of working backwards here. And then this, to get this guy, well, I need 2 numbers that multiply to 9, but add up to negative 6. Well, that's negative 3 and negative 3. So it's going to be y minus 3 times y minus 3, or y minus 3 to the second power. If you're confused by this, you would have to review how to factor quadratics in algebra. And I don't want to get too much into details about that, but if you have any questions, you can ask me in class and I'll give you more of a detailed description of how to do that, okay? So now you notice that this matches this form. You can see it matches it perfectly. So you can see that h is equal to 2 and k is equal to 3, right? So that's exactly what we're going to do. So that means our center is 2 and then 3, because remember our center is hk, and our radius squared is 9, which means that our radius itself, you got to take the square root to get the radius, is 3. So the radius is 3, the center is 2, 3. And that's how you do that. So that's an advanced problem. We wanted to start out with the advanced one before we move on to the simpler ones. All right, so the center of a circle is at -5, 7. So that's the center of the circle, so that's HK. The radius R is 6. Derive the equation of the circle using the Pythagorean theorem. Okay, so we know that the equation of the circle is x minus h squared plus y minus k squared equals r squared. So we're going to derive that or prove that using the Pythagorean theorem. So first off, if we have a circle with the center -5 and 7, let's actually do it that. Maybe I should have brought it lower, I'm sorry. I need more space. This is the center of that circle. And so let's draw that circle. And and then the radius is 6. So if the radius is 6, that means 1, 2, 3, 4, 5, 6. So that means it's going to end here. That's the radius of 6, right? And then it's got to go 1, 2, 3, 4, 5, 6. So it's got to end here. 1, 2, 3, 4, 5, 6. End here. And then here it's going to be at 1, 2, 3, 4, 5, 6. So it's going to be somewhere over here. So then you can draw your circle with a radius of 7 or radius of 6. All right, so there's a circle. Now, what we want to point out is that if I want to derive the equation of a circle, well, let's go ahead and make this point xy, because it's a generic point on that circle. We don't know where that point is, right? And we know that the radius here is 6 because that's what they told us. And so we know that this is going to be x and this is going to be okay, so what we're trying to find is we're trying to figure out this distance and this distance, okay, in order to make a right triangle. So we know that the center of the circle is -5, 7. So that means if I want to get the distance from here to, if I want to get the blue distance from there to there, I would have to subtract the x coordinate of this guy minus this coordinate, right? And that will give me this distance. Okay, so let me redraw that triangle just a bit bigger because I'm limited by the size of the drawing. Okay, so if I want to get this blue distance is x minus -5. Okay? And x minus, the double negative turns into plus. So I'm going to change this into x plus 5, right? The green distance is the y distance, whatever the y value is, minus 7. Y minus 7. So for example, if the y value was 10, 10 minus 7 is 3, and so this green distance is 3, okay? You just subtract the two values. And then we know that the radius is 6. So if I use the Pythagorean theorem here, I'm going to delete this now because it's too distracting. X plus 5. If I use the Pythagorean theorem here, so let's use the Pythagorean theorem. It's going to be a squared plus b squared equals c squared. So this is a, b, and c. So a squared plus b squared equals c squared. There you go. And here it doesn't matter the order in which you do this. So you could conceivably move this x part first, because we usually like to have x first, and then 6 squared. And there you go. This is the equation that we were talking about. This matches the form x minus h squared plus y minus 7 squared, or y minus k squared, equals r squared. Where in this case, my h is -5, because if I plug in a double negative, this turns into positive. And my k is just 7. And then my radius is 6. We can see that the radius is 6 there. So this is the derivation, okay? Using the Pythagorean theorem. Okay, so that's part of the benchmark, so I needed to include that there. Let's finish up the rest of this, and then the last questions on this pack on page 38, and then we'll end this part. We'll finish the other part. We'll finish the rest of the packet in the next part of the video. Which is the equation of a circle that has a diameter with endpoints 1, 3, and -3, 1. Okay, so again, remember the equation of a circle is that, right? And they say that the diameter, so this is the diameter, has 1, 3, and then -3, 1. Oops, didn't mean to do that. Okay, so let's say that's the diameter. And so first off, I need to figure out where the center is. I don't know where the center is. They don't tell us. But they do give us the endpoints. So what we can do is do the midpoint. And the midpoint will give us the circle, the center in the middle, right? So let's go ahead and do the midpoint. Remember, to do the midpoint, you add the x coordinates, add the y coordinates, divide by 2. So add the x's, add the y's, divide by 2. So we got 1 plus -3 over 2. 3 plus 1 over 2. So it's going to be 2 over 2, which is 1, and then 4 over 2, which is 2. So the center is 1, 2, which means we know our h and our k in the equation of a circle. Now to get the radius, you would simply have to figure this distance out, right? And we can use that, use the distance formula for that. The distance formula. So to get the radius, we have to do the square root of, then you got to subtract the x coordinates. You got to subtract the x coordinates for the center and then that point. So it's going to be 1 minus 1 squared, and then 3 minus 2 squared. So in that case, the radius is going to be 1. All right, and that makes sense if you look at it. All right, so the radius is 1, and then we can write the equation of a circle. X minus h squared plus y minus k squared equals r squared. So our h is 1, so x minus 1 squared. Our k is 2, so y minus 2 squared. And our radius is 1, so 1 squared is 1. Oh, sorry, this should be -1, not +1. I knew something was off about that. This is -1 for the h. So h is actually -1. So let's change this to +1 squared. And because this is -1, this has got to be -1 over here. So the radius is not 1. -1 minus 1 is -2, so -2 squared. 3 minus 2 is 1, so it's going to be 1 squared. So 2 squared is 4, and then 4 plus 1 is 5. So this is the square root of 5. So this is going to be the square root of 5 squared. Remember, the square root of 5 squared is the square root of 5 times the square root of 5, which is just 5. So really, we could just turn this into a 5. Okay, and that gives us our answer. X plus 1 squared plus y minus 2 squared equals 5. Okay, all right, so that's that. Number 4, what is the equation of a circle with a radius of 3 and a center of 3, 0? So this is h, this is k, this is the radius. So it's x minus h squared plus y minus k squared equals r squared. So we got x minus 3 squared, and then y minus 0 squared, right? Equals 3 squared. And 3 squared is just 9. So we got x minus 3 squared plus y squared. The 0 doesn't do anything, so we can just write it as y squared. 3 times 3 is 9. All right, so here's your answer. However, of course, in the multiple choice, they make it look different than how we have it here. And so what we have to do is we have to match it together. Okay, so it's a pain in the butt. But what we have to do is we have to FOIL this. This is x minus 3 times x minus 3. So, because remember, it's to the second power, so we're multiplying it by itself. So we got to do the good old FOIL, first outer, inner, last. First outer, inner, last. X times x. X times -3. -3 times x. negative 3 times negative 3. And then, of course, bring everything else down. Since these are all equal to 0, I'm going to go ahead and subtract this 9 and force it to be 0. And in doing so, these go away. So let me just put my work here. So this is negative 3 and negative 3. That's negative 6x. And then we got plus y squared equal to 0. And then, of course, they rearrange it. They put the y next to the x. So it looks like x squared plus y squared minus 6x equals 0. So it looks like the answer is A. Okay. All right, so number 5, given the equation here, determine the possible values of E such that the equation is the equation of a circle. Okay. All right, so for this one's an interesting question because now we have to figure out, okay, what can E be to make this a circle, right? So first off, we're going to need to isolate the x's. So what we're going to do is we're going to do kind of like when we completed the square. We're going to leave a little space there. Y squared minus 4y, leave a little space there. And then let's move the e to the other side. So let's subtract e on both sides. So that's going to be negative e because 0 minus e is negative e. I'm just moving it out of the way just to get it out of the way. Now, then we're going to complete the square. Remember, you got to do the middle number divided by 2 squared. This is what we went over recently. And the middle number divided by 2 squared. And you have to add that to the other side as well. All right, so in any case, we get 2 divided by 2 squared is 1. And then 4 divided by 2 squared is 4. And so you got to add that to the e. So you got to add 1 and 4, which becomes 5. So this is going to be negative e plus 5. All right, so negative e plus 5. Okay, and then we're gonna basically factor this. Remember, to factor this, you need two numbers that multiply to 1 but add up to 2, and that's just gonna be 1 and 1. So it's gonna be x plus 1 times x plus 1, which is x plus 1 squared. And then for this guy, you need numbers that multiply to 4 but add up to 4, add up to negative 4, sorry, which is just negative 2 and negative 2. So this will be y minus 2 squared. And I'm just going to rewrite this over here, negative e plus 5. All right, so remember this, the equation of a circle is x minus h squared, y minus k squared equals r squared, right? So we got the left side down. The right side has to equal to a number, right? So this cannot be equal to 0. This has to be greater than 0. Has to be like 1 or 2 or 3, right? In order for this to be a radius, because the radius of a circle cannot be 0, right? So the radius has to be greater than 0. So we're going to say that this is bigger than 0. And so that means if I solve for e, right, I'm just going to move the e to the other side. So that means 5 has to be greater than e, which means that e has to be less than 5. And those are the values that e can take on. So e could be 4, 3, 2, 1, 0, negative 1. It could be any of those numbers, and then you'll have an equation of a circle. Okay, so that's your final answer. All right, so that one was tricky. Number 6, the equation, it represents circle A. The point B lies on the circle. What is the length of the radius of circle A? Okay, so this is x and this is y, because this is the point on that circle. So what we're going to do is we're going to plug those in there. That's going to give us our radius. So let's plug it in. 4 minus 1 squared, 7 minus 3 squared equals r squared. Just do the math. 3 squared is 9. 4 squared is 16. So we get 25 is equal to r squared. Take the square root, and r is simply 5. That's how you do that. So not all problems have to be difficult. All right, so number 7, which is the equation of circle B? All right, well, what's the radius of this? 1, 2, 3, 4, the radius is 4. Where's the center? Well, the center is here, it's 2, 0. So this is h, this is k, this is my r. So we just gotta plug it into the equation. x minus h squared plus y minus k squared equals r squared. And 4 squared is 16. And then the 0 doesn't do anything, so we can just ignore it. And that's our answer. X minus 2 squared plus y squared equals 16. So A. All right, that's going to do it for the video, guys. I hope you found it informative. And as usual, I'll see you in the next part. The next part should be the last part, hopefully.